In the next few years, AI is going to write a lot of code. But here's what won't be automated. Understanding why an agent behaved the way it did. Why did it choose that tool? Why did it forget something? Why did it hallucinate? Why did it get stuck in a loop? The engineers who can answer those questions will build the next generation of AI products. That's why I think every AI engineer should learn LangChain. Not because it's the only framework, but because it's the framework that forced the industry to think about agents, tools, memory, multi-agent systems, MCP, and a human-in-the-loop workflows. Today, it's one of the most widely used frameworks for building production AI applications, and many of the concepts you learn here transfer directly to other frameworks. And I'm telling you this because I use it at my workplace every day. And here's something I strongly believe. You shouldn't let an AI generate your first agent. You should build it yourself, line by line, because eventually you'll spend far more time debugging agents than writing them. You'll read execution traces, you'll inspect tool calls, you'll understand memory, you'll figure out why the model made a particular decision. That ability becomes your competitive edge. So instead of learning LangChain as a collection of APIs, we're going to learn it in the way software engineers actually build software by building a real product. Meet Aria, an AI executive assistant, and we're not going to build her in one giant project. We're going to teach her. Every section in this course adds exactly one new capability. We start with a single model call, then we teach Aria to use tools, then memory, then multiple agents, then we teach it how to work with MCP tools, and we also bring in the human in the loop factor. We also bring some dynamic behavior, so it picks the relevant tools and does self-correction to improve its decisions. And finally, we'll have a production-ready agent that you can deploy. Every lesson is its own runnable object. You can stop after any section, run the code, experiment, and continue where you're ready. So if you've always wanted to understand how modern AI agents actually work, not just how to call an API, let's build one together. Let's build Aria. All right, what you're seeing on the screen is basically the repo that we'll be using to build Aria. You will find the link to this particular repo in the description. Essentially, the README has clear details on how you can make this work locally. The first thing you'll obviously want to do is you want to clone this particular repository and then run these commands. You need to create a .env or an environment file with a bunch of keys, mainly a key of an LLM, preferably OpenAI API key because it's cheap, and also Langsmith. Though I've written optional, but I'd strongly recommend that you create this account, that is create an account in Langsmith and add the credentials there. I'll also add the link to this particular link to Langsmith in the description. Let me come back to the preview. The other thing that you'd want to understand, and probably the most important bit, is we'll be using real emails from Gmail, and we'll be using Notion to essentially create pages and create some records after reading the email. So these are the two MCP servers that you'd want to set up. There is clear documentation on how you can do that. Once you're done with this, I think you should be ready to make the agents work. All right, with that, let's get started. All right, so what you're seeing is assistant.py, which is basically an agent that we'll be creating. I have already written the code, as you can see, and you'll be seeing this in the foundation section. The idea is that we learn a couple of concepts from LangChain, which is basically where we learn what is create_agent method, and we understand how to use system prompts and also get structured output. But we will do this by giving a skill to Aria. The idea is that Aria should be able to read an inbox. There's no real inbox yet. We will just be giving it a raw email. And the expectation is that she understands what that email is and returns a response to tell us whether it requires our attention or not. Okay. And we'll be adding more skills to it as we go to the subsequent sections. To do that, we'll be using one of the most important, or if not the most important method in LangChain's agent module, which is basically create_agent. As you can see, create agent takes a couple of arguments, which is in fact a lot of arguments, which it takes model, tools, system prompt, middleware, response schema. We'll be using a lot of these as we progress. But to begin with, let's start with a very simple example. As we know, we essentially want to We want Aria to read a raw email and give it a response. Basically, tell us if that email requires our attention. So to do that, we will essentially be using a Pydantic class. A Pydantic, this is basically email triage is the inherits Pydantic's base model, and the fields that it has is priority, reason, and suggested action. The idea is that we get a label, like if it is urgent, reply needed, and what is the reason for that particular label, and what are the next steps that Aria should take, or sorry, the user should take, in this case, me. And we'll also be giving, obviously, a system prompt to Aria first, right? So the system prompt looks something like this. We'll give it a persona. Aria is basically an AI executive assistant. And we'll also tell that it is a executive assistant for another persona, which is Julie. Julie could be me. Julie could be anybody who Aria would work for, but I've just given it a name, right? The idea here and the system prompt is basically telling what are the responsibilities of Aria. Aria's responsibility that it will read one email at a time and triage it, basically uh, classify it, and be decisive. That busy people don't want a wall of text. Give short, direct answers. The idea is that it'll read an email and it tells the user what it needs to do. And in this case, the user is me, right? So let's actually build an agent. To build an agent in LangChain, all we need to do is we use the create agent method from the LangChain modules. And you can create a bare minimum agent by simply passing the model, obviously, because an agent requires a model, and a system prompt of what the what the model needs to do. What is the model's persona? Sorry, what is the agent's persona? And what are the instructions that you want to give the agent? So as you can see, it's a simple method, and I'm passing a couple of arguments. One is GPT-5 Nano, the model name, and the other is the system prompt. What the system prompt looks like is something here. We've already created that. You could write that directly here, but we put that in a variable. And the response format, because we wanted to essentially return a structured response so that we can programmatically use it in the later stages, we are giving it a response format. I can run this without the response format and take a simple text as output. But my goal, the beauty of LangChain is that it can essentially force LLMs to give out a structure that looks like this. So essentially, create agent is a harness where it has a loop, and it would essentially loop till you get the relevant response. In this case, the response is I need to give it a raw input, which is basically a raw email, and I want the output to look or to have these properties, basically a structured response. So in the response format, I'm passing this Pydantic model, basically an instance of the Pydantic model, the email triage model, or class, which is which will have three properties: priority, session, and reason and suggested action. I've also created a simple method called triage email. To this particular method takes in a simple raw email. There is a string, which is a raw email, and it returns the email triage object. Okay. So what it does internally is basically we'll use triage agent, the agent instance that we created here, and invoke that agent by passing the message dictionary. A dictionary basically that contains messages. Messages again is a list of the messages object from LangChain, and I can quickly show you where we have imported that from. You can see here we're using LangChain.messages to essentially import human message. Why human message, you would ask? Obviously, because the message right now is basically going from a human. So it's going from the user, and the message in this case is a raw email. And we've already passed the system prompt of what the model or the agent should be doing with this message. So we've already done that. So we invoke the agent, that is the triage agent that we just created here, and will return a relevant response. So let me quickly run it and see what is the response we get. I'll just bring it up here. All right, so as you can see, the response that we got from the agent is this. Uh, in fact, let me actually show you what we are sending. So my raw email looks something like this. Obviously, this is a mailed up email. It has a subject, urgent, board deck needed tonight. And the body is, can you pull together the Q3 numbers for the board deck? I need it by 6 p.m. today. It's coming obviously from the CEO of company. So The priority is urgent because the CEO is requesting Q3 numbers for the board deck with a 6 p.m. today deadline, and the action is it's telling me to pull Q3 numbers. Da, 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 da. Obviously, this answer is made up, but with the relevant context, with the relevant instructions, the response will be much better. But you get the point. You see, we just enabled Aria to be able to identify, read an email, and essentially give it a label, give it a priority, whether we should, or the user should be able to take or should take immediate action or not, right? So we have accomplished that goal. So we just gave Aria a skill to read an email and return a response whether that email should be actioned upon immediately. All right. Now let's move to section 2. All right, we'll start with the next section, which is the tool section. We'll be adding tool capabilities or giving tool capabilities to our agent, Aria. Now, Aria can actually look up things instead of relying on the raw text that we were sending it in the previous section. I also want to show you, quick example of how we are passing the data to the tool. We'll be setting actual MCP servers later, but for now, to simulate tool action, we'll be using this mock data. As you can see, I've created a bunch of emails objects here in this particular text called inbox, and I've also created mock data for Notion pages and a calendar. There are some helper methods here, as you can see, find email and find Notion page. Now, if I come back to section 2, you'll see that there are two tools that we've created, and this is how we've done that. There is a method called check inbox, and there is another method called search nation, and you'll see that there is a tool decorator on top of that. One thing to note here is that if you add this particular decorator, you're essentially turning that into a tool object. The tool object is basically a method, and it is part of the tools module in LangChain. One thing to note also is that the LLM can only recognize the functionality of a tool by reading a description. And there are two ways to add a description to a tool. One is to either write a very detailed doc string, which is very important, or you could also add a description, as you can pass the description as an argument to the decorator like this. So as you can see, I've added search the use this Notion workspace for pages matching the query, right? The rest of the system is pretty similar to what we saw in section 1. There is a system prompt, and in this particular system prompt, we have explicitly mentioned that it has now access to certain tools, and here we are using the create agent method to essentially create an agent object. We have passed the LLM and the list of tools that we have just created. As you see, we are passing check inbox and search Notion to the tools argument, and the tools argument essentially takes a list of tools, as you can see. We're also using a system prompt, and you could explicitly write the system prompt here, or a cleaner way is to basically write that as in a variable and then just simply pass a variable to the system prompt argument. All right, we've created this basic agent now, and we'll explicitly give this particular command to the agent. The query is, again, you can use a human message object to essentially pass that as input to the agent, and you can invoke the agent. So the message is, or the query is, what's in my inbox right now, and do I have any Notion notes about the board deck? There are two parts to this, right? You can see that there are two completely different instructions here combined into, or two different tasks that have been combined into a single instruction. So let's see if the agent is able to essentially execute this and give us a relevant response. Obviously, it'll use this will use the mock data, but we should be able to see the response. So I just ran this particular agent, and we should get a response anytime now. All right, so we have the response from the agent, and as you can see, it is saying that it has read these couple of emails where the subject is contract renewal, need your sign off. Uh, the second email is 10 productivity hacks you need to know, and so on and so forth. So we'll see where that is coming from. Obviously, we know that we created this uh, mock data. I'm sorry, the mock data is here. And as you can see, 10 productivity hacks you need to know. See out my company, subject urgent, board deck needed tonight. So the last message was from the CEO of the company. So you can see that all of that is there. It has also read the data from Notion, and it is said that it has essentially 3 pages. Page 3, pages Q3 board deck, status in progress, draft outline includes this. So would you like me to open Notion page? So it is basically followed the instruction that we gave. Let me go back to the assistant. And this what's in my inbox right now. So obviously it's read all the messages from the inbox and also read all the Notion pages and returned the relevant Notion page details. So the query had asked about board deck, and if I go back to the Notion pages, only one uh, page among these had content about board deck, which is basically this one, and it has exactly picked up that one, and it is saying the status is in progress, and it has also returned the draft outline for us. So it's done a clean job of essentially using the tool to read the emails, the list of emails, summarize them in a way, and also you know read the Notion pages and give that Notion page back to us. In fact, what we'll do is we'll just tweak the query a bit and see if it is able to, you know, yeah, let's go back here, right? I'll probably open mock data here so that we can see the mock data while we are writing this. So I have this particular query here. I want to tweak that a bit. So I'm saying get the last meeting notes from Notion, summarize the action items from me. So let's run this and see what output we get. So I'm going to run this in the terminal again, and we'll wait for the response to come back. So what I should get is basically, oh, I think I've already have the response. So it has rightfully read the title, which is basically the meeting notes title, and it has written that, and it has also given us a short summary. So the snapshot is discussed Q4 roadmap, and the action items is follow up on integration timelines. Next steps I can take for you. One thing to notice in section 1, and if you can go back to section 1, we were using a structured response, as you can see, the email triage, which was giving us these. That was just to simulate how we could work with structured output. You see, in this case, we've not created a structured output because we want to keep the queries very, very random and not be tied to specific structure at this point in time. So we're returning a text output. We can actually make the agent utilize the text output and give us better results. And you will see how we are doing that in the future sections. All right, let's move to the third section. In a chat application, we know that when we are interacting with an agent, the agent remembers the context from the previous questions that we've asked in a specific session, that is. Can the agent that we wrote in section 2 do that? Let's find out. So what I've done is I've tweaked section 2's agents with this particular message. Basically, instead of calling the agent once, I'm calling the agent twice, just like we would in a chat interface, right? So the query is exactly the same query that we had the previous time. The only change that I have made is that I have added this instruction, written only the summary, and I've created something called a summary rule, and that the summary should not be more than 5 words. In the subsequent turn or the subsequent call again, I'm asking the agent to basically generate the same thing. However, this time I wanted to remember the summary rule that I had, you know, shared with it in the previous turn. Will it remember that? Let's find out. So essentially, we are invoking the agent twice, so I should see two responses, and that response should be divided by this dashes, 15 dashes essentially. All right, I have a summary, a 5-word summary, follow up on integration timeline only, and I'm hoping that the agent remembers the same summary rule again and returns a 5-word summary only. Let's see if it does that. No, the agent did not adhere to the rule. Follow up with Sam from partner.io on the integration timeline. So we know that it is essentially picking up the right action, which is basically it's picking up the latest meeting notes, but not adhering to the summary rule. The reason being that the agent doesn't remember anything unless and until we add a memory component to it, and LangChain does that beautifully. So let's see how LangChain has implemented that. So I'm going to section 3, memory, and there are a couple of concepts that we'll have to understand first. So in this particular section, we'll understand the concept of checkpointers, thread ID, and short-term memory. For AI agents, memory is crucial because it lets them remember previous interactions, learn from feedback, and adapt to user preferences. LangChain uses short-term memory, that is the thread scope memory, to manage persist conversation history for resuming sessions, while long-term memory, store-based memory, that is, preserves user-specific data across multiple threads. So if I'm having a conversation right now, it'll basically keep that short conversation in memory. That is a conversation tied to a session in memory. And if it is multiple sessions, it'll take them and persist them in the database. It can also persist thread or session-based thread scope conversations in persistent stores as well. As you can see, we are using this particular in-memory class from LangChain to essentially store our conversations that we have with the agent in memory. You could replace this with a persistent store like Postgres or SQLite as well, but for the demo, we'll be using in memory. And how we use this is like this. In the create agent method, we pass this as an argument to the checkpointer. A checkpointer saves a snapshot of a graph state at each step, organized into threads. And a thread is something that you can actually pass as an ID in a configurable to and when you're invoking the agent, that is. What is a thread? A thread is basically a unique ID or an identifier assigned to each checkpoint saved by the checkpointer. It contains accumulated state of a sequence of runs. When a run is executed, the state of the underlying graph of the assistant will be persisted to the thread. So what happens is every time the agent executes a turn, the thread, basically the entire conversation, that is the input from the user and the response from the agent, is stored in memory in this case. And if it is a persistent store like Postgres or SQLite, it gets stored in SQLite or Postgres. So here I'm simulating two turns. The first is basically me sending this particular query with this instruction. Summary should not be more than 5 words. And another turn where I am basically passing the same input, but I'm expecting it to remember this rule again, where I'm saying keep the same rule as before. Okay. One important thing to note here is that we have added the checkpointer as an argument, or basically checkpointer. We'll be using the checkpointer argument, which is basically it takes in an in-memory saver or different checkpointer like Postgres or SQLite, right? If you go through the documentation, you'll see a lot more options. And we need to pass the thread ID, a unique thread ID. This could basically be a custom string like this, or you can also pass a GUID here as a string, essentially. And you need to use that in the configurable key and pass that as a config when you're invoking the agent here like this. Okay. So as you can see, I've added that here. The idea is that you add that as config, and if you're working in a loop, you don't have to add it at every turn. But because I'm still not working in a loop, I am simply passing that here as is. Okay. Now I want to change this name here. I don't want to use user1, so let's give it test thread 1. Okay, and let's run this. So my expectation is that I should see two summaries. One, oh, as you can see, it has returned this summary follow up on integration timeline, and it has returned 5 words only, which is good. Now let's see if it remembers the same instruction, and it has follow up on integration timeline. To understand this deeply, I think one easy way to see if the subsequent turn actually received that as input is to basically use use langsmith, and that's what we'll do now. I'm checking out langsmith, and I'm checking all the details here. The thread ID that we passed was test thread 1, as you can see. Let me see if this is using the same thread ID. Yes, it is. Okay, let's try and understand what has happened here. As you can see, there are two LLM calls that we made. The first LLM call, the input was get the latest meeting notes from Notion and summarize any action items for me. The summary rule is this, and the response we got was this follow up on integration timeline. In the subsequent turn, you will see the input was get the latest model notes from Notion and summarize. Remember, this was the input that I gave as a user, right? However, what was sent to the LLM was not just this particular input, but also the history, the conversation here. So if I show you what was the input to the LLM, the input to the LLM had the system prompt, it had the immediate query, it had the query from the first turn, which is basically the entire conversation, that is the user query, and the response, the tool calls, basically all the tool calls, and the response from that particular agent, which is basically follow up on integration timeline, right? The entire turn, which is the entire input and output from the agent, input to the agent and the output to the agent, including tool calls, have been added as context to the memory because we store context to the LLM because we stored that in the memory and we're able to push that. Now, this is the actual input, which is basically get the latest meeting notes from Notion and summarize it, keep the same summary rules. The LLM was able to remember the rule because the rule clearly says here that summary should not be more than 5 words. And it was able to return the response. The response is here. Follow up on integration timeline. The same thing again. All right, I hope this was useful. Let me go back to the ID here. So in this section, we were able to add memory. In the following section, we'll actually create a multi-agent system. In the previous section, we added memory to Aria. Aria can now remember things, but there is also a problem. Aria has access to too many tools. Aria has the responsibility of remembering too many tools. Now imagine that here, if I go back to the assistant.py here, these are just two tools that we have given Aria access to. But in the real world, an MCP server of Gmail can have several tools. An MCP server of Notion could have several tools. If we pass explicitly all of those tools as prompt or as part of the system prompt, that's just too much information for an agent, right? We don't want to do that. We want to ensure that the agent doesn't get confused in picking the right tool given the query. And that's why we built a multi-agent system pattern. So the idea here is that we create specialists out of the different domains that or different tasks that we are working. For example, all emails can be essentially all email related operations could essentially be isolated into an email specialist. All Notion related tasks could be isolated into a Notion specialist. There is this bonus calendar agent that I've added, but you could ignore this. But let's assume that you also had a calendar tool, and if you wanted to essentially extend that uh, into an agent of its own, you could do that. The pattern is not very different from what we've already seen. There is a tool. We are using the same check inbox tool, which returns the mock inbox data. But we will create a specialist agent by using the create agent method. We'll pass the model name. We also pass the tool arguments, which is basically the check inbox tool that we have just created. And we give this particular agent its own system prompt. So in this case, you're an email specialist, read the inbox and answer questions about it concisely. But here's what the interesting part is. We essentially create another method called call email agent, which basically takes a question as input and invokes the email agent and returns the response from the email agent. However, the entire thing is basically we however we basically turn this into a tool, and this tool will be used by the supervisor agent that we will be looking at in a bit. Same goes to Notion specialist. There is a search Notion tool. We create a Notion agent with its own system prompt, and we pass the search Notion tool as a tools argument to the Notion agent. We also have written a call Notion agent method that essentially takes a question and invokes the Notion agent and returns the response. But that is also behind a decorator, the tool decorator here, as you can see. We have essentially created two tools out of the agents, which is basically call Notion agent and call email agent. There's obviously the third agent called call calendar agent. But the idea is that we write a supervisor agent that becomes the main interface of Aria, which is basically that the outside world would first connect with the supervisor agent, and the supervisor agent will delegate task or hand off the task to the relevant agent or relevant tool that it has access to. Let me walk you through the supervisor agent prompt. It's basically the same persona that we had previously. Instead of the two tools that we were telling it about, now we'll talk about the two tools, the three new tools that we have created. Essentially call email agent, call Notion agent, and call calendar agent. We are passing that as context in the prompt itself. And we are also passing the list of tools, call email agent, call Notion agent, and call calendar agent here by in the create agent method. There is the model and the Aria supervisor prompt, and obviously the memory that we saw in the previous section. And here we simply invoke that agent again by using the configurable object, which is basically the thread ID. And in this case, I'm going to write multi-agent thread 1, and we'll be testing that with two different turns. The first one is, do I have any questions urgent in my inbox, and am I free to prep for the board deck tomorrow morning? And we're giving it a rule, keep replies under 3 sentences. We'll basically test it the way that we did, but you'll see that it is handing it off or handing off these tasks to the relevant agents. So as you can see, I have two operations here: check the inbox and also uh, check if I have a deck, which is basically it needs to check Notion as well. And in the second task, we are only asking it to check Notion. So let's see if it is able to perform those tasks. All right, so we have the response. The first reply is obviously under 3 sentences. All right, so we have the response. Is board deck and board deck data is here. Okay, so obviously this is mock data, so we don't have to worry about this. But uh, now let's look at the flow of calls in the thread that we just executed. So I'm going to click on the latest one, and we'll see that there are two LLM calls that we are basically two turns here. This is the first turn LangGraph, and there's such a big flow here, and there is the other turn here, which is another call that we made. But I'll just collapse the both and look at just the first one. So the first one, the query was, do I have any user anything urgent in my inbox? Keep replies under 3 sentences. And the output that we have got is, do I have anything urgent in my inbox? And keep the user output was this. Basically, it's saying showing the user or the human message. And in the AI message, this is the output, call email agent. It basically invoked the call email agent first. And here you can see that it invoked the call email agent with this one, and it also invoked the call calendar agent with this method. So you can see the question that it composed is, do I have any urgent items in my inbox? Please summarize urgent high priority items. So the agent essentially composed this particular query to the agent, that is call email agent. And the agent also composed this particular query. What does demand? Remember, we did not send this. The agent composed this question to the sub agent. And the response from the call email agent looks something like this. Yes, here are the urgent high priority items. So the agent took its time. It then invoked the tool on its own, basically called the MCP server on its own, and returned this response. Obviously, this is, it's called the mock data, but you get the point. Same with this one. Call calendar agent essentially made up some data and sent it back. We don't actually have the call calendar, system at this point in time in the MCP server. We're, the limit, the scope is with only email as well as, Notion. But the idea here is to show you how this works. The final response, from this is board deck Q3 numbers. It basically summarizes all of that here. And if you can look at the flow here, we called OpenAI. Basically, OpenAI suggested that these are the two tool calls that we need to make. LangGraph then basically within its loop called those tools, as you can see, check inbox in this case, and it also got the response. And in the subsequent one, it basically called check inbox again, I guess. Basically, here's what the tool call happened. And the final response was here, right? In the subsequent tool call, which is basically call calendar agent, remember there were two tasks, right? A calendar and as well as a email related task. Again, the tool was invoked, LangGraph then basically composed this particular question, sent the tool that particular question, tool returned that answer. LangGraph then sent the tool call response back to the LLM, OpenAI GPT-5 Nano, and LLM basically composed this final response. And the same thing again, in the final turn, in the first turn, that is, the final response looks something like this. Now let's look at the second turn. I'll collapse this. In the second turn, the question was, now check my Notion for board deck notes and keep the same reply. So here I'm giving it a Notion task. And let's see what LangGraph sent to the model. The model, basically it sent this, right? So it called the tool Notion. Okay, so let me actually show it from here. So we got this. The model essentially said that you need to call Notion agent. Then it basically started making tool calls. As you can see, it called the call Notion agent tool call, and it got the response from Notion here. I think it took some time, but it eventually got the response. That's why I think the delay. You could see that it was trying to make the call to Notion several times. I think it got the output somewhere here, I guess. Yeah, those are several calls, seems like. And finally, you can see upcoming board decks, board notes, boarding made rep. So it made so many calls, and finally at this stage, it got the response. And this is the final response it returned. So you can think that you could have a very complex system using Langsmith. You can essentially trace, look at all the different paths the agent essentially took to arrive at the final output. This is going to be very important tool for you to essentially evaluate and build this observability feature into your agentic system. Let's actually move on to the next section now. In this section, we'll cover model context protocol, essentially how you can add multiple servers or multiple MCP servers to an existing agent. Uh, the explanation of what model context protocol is and how it works is out of scope of this particular course. But before we talk about the integration of MCP into our existing agent, I want to first show you two things. One, you will see that we'll be using Notion's official MCP server to connect with my Notion account, as you can see. And just to show you, I have an email from mermaid.ai, which I have turned into notes, basically an email summary, and I've added that as a page in my Notion application, as you can see here. The other bit I want to show you is I have a demo Gmail account, basically a proper valid Gmail account, but this is a demo account where I do not do any personal transactions, right? So uh, you can see that the last unread email that I have here, or the latest unread email, let me put it that way, is this one, two-step verification turned on from Gmail or from Google, essentially, right? So just want to set the context that we will be working with real MCP servers now to connect with one, Gmail, and access the emails here and read those emails and summarize them. The other is reading my Notion account using Notion's official MCP server and using that to essentially read this particular page, which is an email summary about mermaid.ai. All right. Now let's go back to the code. In the previous section, we had covered how you can essentially turn your agent into a multi-agent system. If you want to essentially create specialized agent, if you want to essentially offload a very domain-specific activity or work to a different agent altogether, and you should be able to do that using a multi-agent setup, that we saw. However, there could be scenarios, and let me open this again. However, there could be scenarios that you might want to essentially use an MCP server or multiple MCP servers using a single agent also. So just to ensure that we are keeping things simple in this particular tutorial, we will turn this into a single agent again. You can continue to use multiple agents or a multi-agent system like we had learned previously. But I just want to keep things simple here because the idea is I show you capabilities of the LangChain framework and how the harness has all the integrations ready for you with very minimal code that you have to write. All right. So in this particular section, and that is in section 5, Model Context Protocol, we'll learn how to use LangChain's multi-server MCP client class. What is STDIO transport? Basically, how to use the STDIO transport protocol of the MCP servers that we'll be working with, how to connect with an agent, basically how to connect with the MCP server using our agent, and how to use the tools to make tool calls and get a response. Okay, so a couple of the only new import that we are doing or importing a class or from a module is this one, multi-server MCP client, which is basically again coming from LangChain MCP adapters.client. LangChain MCP adapters is a package on its own. So if you go to requirements.txt, you'll see that we are importing this particular library, or basically we have downloaded this particular or installed this particular package, right? So let me go back here. So that's the multi-server MCP client that we are using, and within this class essentially takes arguments, uh, an object which entails uh, multiple MCP servers. It could take multiple MCP servers. So as you can see, I'm passing both my MCP servers, which is a Gmail MCP server and an Ocean MCP server. The MCP server object looks something like this. You need to specify what transport that you're using, which is in this case both stdio, and what command that you'll be using. It could be a Python command or an npx command depending on the transport that you're using. Essentially, currently model context protocol supports only two transports officially, which is streamable HTTP and stdio. In this example, we will be using stdio and not streamable HTTP. You could basically use streamable HTTP as well. But here, what we want to show you is how you could connect with remote MCP servers. You can see that I'm using this particular package, Gongze server Gmail auth MCP package for MCP server. You could use the official MCP server also, but this looked like a easy setting, so I've used it. But I recommend that you use the official MCP server from Gmail. And for Notion, we are using the official MCP server, as you can see, mcp.notion.com/mcp. And this is basically the argument. We are using obviously a remote connection using stdio transport, right? Uh, Again, we've come back to our original single agent interface where we have a system prompt, and the system prompt we are telling your Aria, we have a persona, you reach your tools over MCP. There are check-in box and send emails. We're explicitly telling what tools it needs to use. You could choose not to do this and basically bring in all the tools, but we know that these official MCP servers can have a lot of tools, but we are explicitly telling what tools it needs to use, right? You'll also see one thing, the difference between us writing our own custom tools versus using MCPs, that we are accessing those tools over a remote connection now using the MCP protocol and basically an MCP server, which is, so Notion obviously is working on Notion's server, and Gmail is working, the Gmail MCP service is from the Gmail servers, right? So you can think of this as tools that you're accessing from a remote server, right? And MCP is basically the standardized protocol. It's an open standard now, where most of the companies have already, adhered to it. Almost just about all the major enterprise tools today have their own MCP servers. You look at Salesforce, SAP, all have their own MCP servers. Notion, obviously being a very popular tool, has their own MCP server, as you can see. So with MCP server, if you're leveraging official MCP servers, you have very little work to do, right? For example, if you can think of this particular use case that we're trying to solve for, this is an executive assistant, and an executive assistant needs to basically have access to just about several, uh, tools, right? It could be Salesforce, it could be SAP, it could be, many different tools. And you don't have to worry about writing that overhead. You just need to access those tools through an MCP server, the official MCP servers of those platforms. In case you don't have one, you could build your own MCP server and you could deploy that, and you can access that remotely, or you could use stdio to set up one, right? That is the use the stdio transport to set up one locally as well. The idea is that you don't have to write those tools explicitly that we saw in the previous sections. That is, those tools are now being accessed over remote servers, and we will execute them in their own servers and not do that locally. If that made sense, right? So let's actually now understand how to build the server. You can see I have this method. The method is called build agent, and this method essentially uses the MCP client that we have from here, basically. Now this client has objects of two MCP servers, and our goal is to basically get all the tools, basically get the tools from these two servers and access that here. You can see that it is returning a create agent object, basically, where we are passing the model, the list of tools that we have captured here, and a system prompt that we have written here, right? What I can do is I will print the list of tools and we'll see what those tools are. Okay. We have a simple main method here. We are essentially building the agent first, and we are passing this particular question. So as you can see, what's the last? I don't want to say last. It's actually what's the latest unread message in my inbox, and do I have Notion notes from mermaid.ai? So I'm asking these two questions. And what should essentially happen is if I go back to my Notion, uh, the the agent should be able to read this particular summary from Notion and read this particular email, two-step verification turned on, hopefully, and that this is the latest unread email that I have in my Gmail account. Okay, so let's run the agent. I'm also printing the tools, so we should see the list of tools that these two MCP servers offer. Okay, let's get started then. Okay, you could see that it has printed a lot of tools here. There are a lot of tools. As I told you, and this is super interesting, right? Because it's very important to understand what's happening here. You see, there is a reason why we use multi-agent system, right? Because look at this, so many tools, and this is just from two integrations, Notion and Gmail. We have so many tools that these two MCP servers are offering. And all of these tools were essentially put into the context of an LLM, of the agent essentially. Now, the agent is still working to get the details for us, but this is a lot of context for the LLM. That's the reason why the multi-agent systems are built, right? So that you isolate the overhead of an agent having access to so many tools to its own domain. So, for example, we, like you saw in the previous step, we built Notion agent and a Gmail agent for this very specific reason, right? So I think let me come back here. As you can see, it has finished the job, and we'll see what happened. Okay, as it rightly has done, the latest unread email is basically this one, two-step verification turned on, and it was basically yesterday, Sunday, 16th of August, 2026 at 11:28 GMT. So let me go back here. This is that email, and obviously I'm seeing IST here, but this is basically the two-step verification uh, email that we saw. Obviously, this is the last or the latest unread email that I have in my Gmail account. We'll also see that it has also summarized the mermaid email. It has found that mermaid email, mermaid.ai. Essentially, it found that in Notion, and it also, giving us that Notion link. As you can see, this Notion link, it ends with 54FC4. And if I show you, it ends with 54FC4, right? It has got that link. It is telling this is the snippet that you have, and this is the latest index. I could have basically asked it to summarize, but I just got that part out, right? So you can see that our MCP server is working absolutely fine. Our agent is able to essentially divide the task into two. First, go fetch that Gmail, the latest unread Gmail mail from my Gmail. And the other one is basically getting this mermaid.ai notes from my Notion page. Okay. Uh, One thing that you probably saw is I have not added memory. That is something that I have deliberately not done as part of the demo, but you could add memory on your own. You don't have to essentially run this without memory. I don't see a need for memory here in this example to show you how MCP set. This basically example is just to show you how we set up MCP servers in an agent, right? Now, just to understand this, we'll also go back to our Langsmith interface, and we'll see what are the tool calls this made. So you see that there was a latency of 66 seconds. Obviously, these were remote servers. When you deploy this application to a server, you should see a much, much better result. But let's try and understand what has happened here, right? So yeah, as you can see, this is the first call that happened. We're asking what is the latest unread message in my inbox, and do I have Notion notes about mermaid.ai? And the first call that was made to the LLM looks something like this. The LLM responded with these tool calls, right? It said, okay, so you have these tool calls, read email, create, get or create label, Notion search, right? And there are 43 other tools that we saw. You can see that there are so many tools that we gave access to this particular LLM. That's a lot of tools. And that's why we built multi-agent systems. This is basically the system prompt that was sent to the first LLM call that was made. The LLM then responded with these, right? It said get or create label. You can have Notion search and you can read email. So these are the three different tools that it basically sent back. It also basically created what are the queries that you need to send. So in this case, it's saying that, query is mermaid.ai, query type is internal, page size 5 for Notion. Okay. Now let's see what are the tool calls that our agent called. So in the first one, it basically looked at this one, get or create label. And this particular tool was executed, successfully created new label, label 1, uh, and place order type undefined. I don't know why it did this. So I think this is basically a mistake that our agent did. It shouldn't have created this. Then the next tool that it executed was Notion search. The query sent to that particular tool was mermaid.ai, and it got this particular result from the MCP server, Notion MCP server, which is perfect. The other tool call that it made was reading that email, right? So I think it tried reading the email the first time, and it seems like it didn't work as expected. So it didn't work as expected. So what it did was it sent all of that as context again to the LLM. The LLM then basically thought, okay, it should basically return get email. So you can see that the input to the LLM at this point in time was the tool results that it got from all the tools and the system prompt and the original query from the user. And the LLM decided that, okay, it's still not solved for basically the given task. It needs to basically return it with another tool. So it returned with another tool, which is search email tool. The the agent then called the search email tool again through its harness, as you can see, search emails. And at this time, the query was inbox and unread. And it got that particular, basically the latest email. As you can see, it has you know, full response. You'll see what are the attributes here. Okay, these are LangSmith attributes. We don't have to worry about that. And if you look at chat OpenAI again, you'll see that the full context, basically the full context was sent to the LLM again this time, where get or create label notions, basically the tool results from the previous turn, and the previous iteration and system prompt. And this time, if I go back here, the output is it returned the read email tool again. Read email, because it got the ID again. The reason, and let me go back here, right? So the reason this worked is because see, search inbox result this and search email returned this particular ID. Now this ID has to be read for details, right? That's why the LLM returned, okay, I still don't have full information of what that email is. I just have some metadata, basically an idea of what that email is, because that's what search email returns. So this time it said you need to use the read email tool. The agent harness then called the read email tool, as you can see, and we have the full detail of what that email is. It was a tool call. And in the final turn, or in the final iteration rather, let me correct myself. In the final iteration of that loop, it has sent the full context again. Basically, the harness has sent the full context again to the model. And the question is, again, the original question. All the tool results, get or create lab, Notion search, read email, get or create label, Notion search, read email again. And this time, uh, the LLM returned with this final response, as you can see. And this is something that we saw in the prompt. And this is something that we saw in the terminal, as you can see. Latest 100 inbox messages and this particular, notes here. And yeah, so that's how you use an agent to connect with multiple MCP servers, pass all the tools that these MCP servers have as context to the LLM. So you can see the context was getting bloated up. Just to show you the token count that we've had, we've used close to 100,000 tokens here, which is a lot of tokens. Uh, and if I can give you a breakdown of the tokens, you see the context every time was just increasing. The first time the model had was sending 25.5K context. By the end of it, it was 27K. So all put together, there were 27K or close to 25K tokens that we were sending. So all put together, this entire thread took 100K tokens. That's a lot of tokens. And that's one of the reasons why you need to be picky about what tool you're sending as context to the LLM, at least from an MCP server. So that's why you build these agents, and that's why you only pick and choose the tools that you know that you will access or you'll work with. Very important to have that distinction. All right, with that, let's move to the next section. In the previous video, we gave Aria access to official MCP servers, that is the MCP server of Gmail and the MCP server of Notion, which means that it could do all the operations that these MCP offers today, which is both read and write operations. That means it could read emails from my email account, and also, given the right tool code, it would also write those emails, write emails or compose emails or reply to emails. Same with Notion. It can read my Notion pages, but also create Notion pages, right? Create databases, create tables. So through these MCP servers, the agent has, or Aria has, access to both read and write operations of these MCP servers. Now, in a production setup, this could be too much power to an agent sometimes, because there could be tasks where you don't want to give it full authority to execute them. And you would want to essentially be involved in approving certain tasks. For example, I don't want Aria to write any email or reply to any email without my consent, right? That's something that I want to have control on. I'm okay with it reading emails and creating a summary and responding that summary back to me, but I don't want that to be writing back to either my Notion account or my Gmail account without my approval, right? That is the concept of human in the loop, essentially. So in this section, we learn human in the loop middleware and what is the interrupt on method and how to resume an agent after it is, there is an interruption. Middleware essentially is a composable hook that wraps agent's execution loop, letting you intercept and modify behavior without changing the model or the tool themselves, if that made sense. It runs at defined points in the agent loop. And in this case, we are using a middleware, which is a human in the loop middleware. And it runs at these defined points, basically when these tool calls are happening, right? So it could run before or after a tool. So it could run before a tool and it could run after a tool. And we'll probably see some more actions in a bit. But if you focus on the human in the middleware layer, uh, I'm essentially creating this middleware where I'm using the interrupt on parameter to pass these instructions. For all the read-only tools that I have access to, it doesn't have to, ask for, or it doesn't have to interrupt, essentially. It can move on. It can basically continue with the flow. But if there are write tools, basically tools that, write into either my Gmail or my Notion accounts, I want I want an interruption so that I can approve that, right? So the idea is we use this middleware as part of the creating an agent instance by passing these middlewares. And in this particular section, we are using human in the loop middleware to the middleware parameter as an argument. Okay. One key element here is that memory plays a very important role here, because you can imagine that the the agent will stop its work when it is basically hitting this particular tool, because this is a gated tool now. And once on my approval or denial, it needs to basically continue from that exact same spot where it stopped, and it needs to return a response. So that's why memory plays a very important role here, because at each and every iteration, it needs to be able to capture what the state is, give a snapshot of where the state is. And at each and every turn, for example, when the control comes back to the user for approval, And depending on the input of the user, it needs to continue from that exact same step. So this is how you define a middleware, and in this case, a human in the loop middleware. Again, just to reiterate, we everything else that we have done is previously the same thing. And obviously, instead of using the actual MCP servers, we'll be using the mock data so that we can, test it really fast. And there is a system prompt again, and we'll be using the create agent method again to pass the list of tools that we need to give access to the agent. And we'll be using the check pointer, the in-memory saver, essentially, to take snapshots of the agent state at each and every turn. And most importantly, we'll be using the human in the loop middleware by passing that as an argument to the middleware parameter. The human in the loop middleware is a class that takes interrupt on as a parameter, which is basically a dictionary where you can pass all the list of tools that you have and give it a flag, a boolean. Basically, you can say false or true. And for any tool that has a true, this is where the gate is established. Basically, this is where the interruption will be kicked in. Okay. Because we're using memory, this becomes a mandatory. That means we need to have a thread ID, and this is the thread ID that we're using. The agent will be invoked with a very simple prompt again, or a query from the user: reply to Sam accepting the coffee for Tuesday. And this is something that we are doing here. You see, they were looking for this particular flag, which is basically we're seeing if this interrupt method is present in the result. If it is, then we basically get the content of what that interrupt is, basically get the value of what that interrupt is, and then we print that back to the user. The user takes a decision. We are obviously, if we've decided what the decision, we want to approve it, and this could be approve, edit, deny. You can go through the documentation to know more about what those basically different types of decision types available, but mainly those are approve, edit, reject, and respond. All right, time to run this particular agent, but instead of running this, I want to debug this so that we can see what the interrupt method is and how we are approving that particular method, right? So I'm just going to put a breakpoint here and run the debugger. Okay, so we are here. I put the debugger here, sorry, breakpoint here now. So this is the config method. Now we'll be invoking the agent and we'll wait for the result to come. This could take some time. All right, so we have the result from the agent, and the agent result object looks something like this. You see, it has the interrupt key as well. So let's see what it does. So I'm checking if interrupt key is present in result, then you need to capture what that interrupt message is and show that to the user. Okay, so obviously there is the interrupt key that we just saw. We'll capture what that message is in the interrupt messages, and we'll also print that for the user. So we're saying Aria wants approval for, and we are printing that particular value. The value is this. Now, obviously, you're seeing these as objects, but if you're working on a user interface, so you need to send a specific part of this particular object only. So in this case, we are sending this. These are the allowed decisions that you can take. And we've already written this code here. So we're saying that the decision from me is basically I approve it, and I expect Aria to reply to that email. So now I've sent that approval back, and using memory, Aria will essentially reply that to that email. So it continues from exactly where it had left off. And as you can see, I'll print that final message now. It has all set. I've sent to Sam, and it is saying that this is the email that it sent to Sam. So we are good. Obviously, we are simulating this. We are not using real emails here. In the previous section, we saw Aria has access to a human in the loop setup where for sensitive tasks like writing an email or replying to an email and writing back to Notion, it essentially brings a human in the loop. It basically checks for a human's approval before it executes whatever the human's command was, right? We know that that is very efficient and this is good. But an important question also is Aria using its resources well? Meaning, is Aria using the right prompt or the right model for the right task? For example, let's take a scenario, right? So let's say that Aria is reading a list of emails, and those list of emails entails, generic emails like a newsletter, and some very important emails from the CEO. Now, the task could entail, writing good summaries of the CEO's email or replying back to the CEO email using a very powerful model, a frontier model. Does Aria have that feature today? It does. It doesn't, right? Because it's using the same behavior for a newsletter or same behavior for a CEO's email. It is basically using the same model, same prompt. We don't want that. We want Aria to be efficient and be judicious in picking the right prompt for the right task. By doing this, Aria is not only generating high quality responses and high quality, writing high quality emails or writing high quality summaries, but is also being token efficient, meaning that it is not spending a lot of tokens for trivial tasks. For example, I don't want it to consume when reading essentially a letter like a newsletter. I don't want it to spend a lot of tokens. I want it to basically understand that if it is a newsletter, that you can use a weaker model or a cheaper model, right? So how can we establish that? There are a couple of ways you could do that, and this is where this is what we'll be learning in section 7. Section 7 essentially talks about a few concepts used in LangChain, that is the dynamic prompt, the wrap model call, and state schema. We'll start with we'll start with the state schema. We'll start with the state schema. Every agent manages its execution through the agent state that you're seeing here. So you can see from agent, we're also importing an agent state, and we've created this particular class, which is essentially an extension of the agent state. Uh, every agent manages its execution context through agent state. It is essentially a typed dictionary that holds the current conversation history and any custom field your tool and middleware need. So in this case, it already holds the conversational history, right? I don't have to explicitly write that. The agent state has that already, but I'm extending its capability by, creating this new property called isVIP. IsVIP is something that I want to use to check if an email is from an VIP. Obviously, I mean, just this is just for a demonstration. A VIP could be the CEO of a company or a very important customer. So you could label who a CIP is, sorry, who a VIP is in your through your emails, or explicitly tell that in the prompt. But the idea here is that we are simulating what a VIP would be, right? And we are extending uh, the state property essentially, yeah, the agent state property. Uh, we just did that. We created this class called triage state, and we added a property called isVIP, which is a Boolean, right? Now, let's also understand what a tool runtime is. I wanted to first go through some of the concepts, and then we'll go through the entire exercise again. Tool runtime is basically, and as you can see here, right, and I'm importing that from LangChain tools. Tool runtime is basically a context that gets automatically injected into the tools, right? You probably are seeing this for the first time that we have been using. Uh, since the last six sections we didn't use it, but we are using this for the first time here, and I'll tell you why. When a tool function has a parameter, this that is runtime, with a type hint called tool runtime, it means that the tool execution system will automatically inject an instance containing the state, tool call ID, and config. So what happens is, if I'm using the runtime here as an argument with the tool runtime as a type hint, as you can see, then the state of this particular agent gets added in at runtime in this particular tool. So as you can see, this particular load email method is not returning a string. It's not returning the result of the tool call. It is actually returning a command, which is basically which has the update object with these properties: isVIP and messages. IsVIP is, we know, is basically part of the state here, which is a boolean, and we are saying isVIP, as you can see. When it basically gets this particular condition, email.get VIP, it then essentially updates that state here, and it also returns the tool call, which is basically the tool call ID that we have. Uh, Whenever this particular tool call gets executed, it returns the result of the tool, but also updates the state. That's why we use the tool runtime, so that at runtime, the state of this particular agent, the agent state that is, gets injected into the tool, and it also gets updated or whatever operation that you intend to perform. That's what is happening in load email. The other concepts that I wanted to quickly have a look at is dynamic prompt, and I will show you where it is being used. As you can see, dynamic prompt is basically a decorator that is used to dynamically generate system prompts for the model. This is nothing but a convenience decorator that creates middleware using. Yeah. So what it does is basically this is nothing but a convenience decorator. The dynamic prompt is a convenience decorator that creates a middleware using a wrap model called specifically for dynamic prompt generation, right? The decorated function should return a string that will be set as the system prompt for the model request. So whenever you use this, any method that you basically use this decorator on, it should return essentially a string, and this string will be used as the system prompt of the agent that you have created, and I will see. This is basically a middleware. I mean, if I can oversimplify it, it is basically a middleware. You'll see that we are importing that from the LangChain agent middleware module, right? Same with wrap model call. Wrap model call essentially converts, and I'll show you where it is being used. You can see here, wrap model call converts a function with a handler callback. As you can see, we're using a handler callback here as the argument, essentially, where it basically converts a function with handler callback into a middleware that can intercept model calls and implement retry logic, handle errors, and rewrite responses, right? So we are wrapping this model call with these capabilities, basically to intercept the model call, implement the retry logic, and handle errors and rewrite responses if it has to, if that makes sense, right? So very important that you understand these middlewares that LangChain has to enable dynamic behavior in an agent. Okay, so let's first understand what this agent is going to do, and we'll quickly see how all of those new functionalities of LangChain that we just read or just understood are being used. So again, this is a very simple agent, the same agent that we've been using, but in this case, we want it to be a little, judicious and also a little efficient in using the right model call for the right task. Okay. So what we have done is we've basically created an agent state, and we've created this property isVIP, which is a boolean, and we want this to be updated when we are loading an email. So let's look at all the tools that we have. We have check inbox, load email. There are a couple of new tools that we've introduced here: draft thoughtful reply, and draft quick reply. Thoughtful reply is when it's an email from a VIP. We don't want to reply, just like that. We don't want a quick reply. We want to reply, thoughtfully, meaning that, we want to essentially, ensure that we understand the scenario and then reply, just like we would, right? Let's assume that you're replying to an email from your boss or your boss's boss. Then obviously you want to, uh, you know, thoughtfully reply to those emails. But if you're replying to your colleague, and if it's basically uh, you know, you're replying to somebody who is not very important, you can use a draft quick reply method here, basically for non-VIP senders, right? So these are the 4 tools that we've created, and we've already discussed this load email bit. Now you will see that in create agent, we have basically we are using GPT-5 Nano, which is obviously the main LLM that we'll use. And we are also using the 4 tools that we just saw: check inbox, load email, draft thoughtful reply, and draft quick reply. We are also using the state schema parameter to essentially pass the triage state that we created in the beginning, which has the is VIP bool here as an argument. And we're also passing the 2 middlewares that we created, and we'll look at what those are. The first middleware is VIP aware prompt, and the second one is VIP aware routing. Now let's look at the first one. You see, we are using the dynamic prompt decorator to essentially allow the model to pick the relevant system prompt here, right? So this particular middleware, which is VIP aware prompt, is basically will basically return a system prompt for us, or basically a text for us, and it'll be one of these two. The condition for that is if the state that we just saw, request.state, is VIP, then we return the VIP prompt, else we return a standard prompt. So this happens, remember, dynamically at runtime. This condition is not explicitly set. It happens right in the object. It is not happening outside of the agent object. It is happening within the harness itself. That's why it's so important to understand this concept. The other part is VIP aware routing. As you remembered, our goal was also to pick the right model for the right task. And my goal is to pick, I want Aria to pick for any VIP related task. I wanted to pick a better model, which is GPT-5. And for a standard task, I wanted to pick GPT-5 Nano, which is a relatively cheaper model, right? So if you look at this particular method, which is basically a wrap model call, you see that we are looking for the state first, whether if it is VIP. And if it is VIP, we pick up the relevant model. That is, if it is VIP, we pick up the VIP model, which is GPT-5. And if it is not the uh, if it is not VIP, we pick up a standard model. And we are using, you can see here, the init chat model uh, method from LangChain, essentially. So we get the LLM object here, the model object, and we pass that as a request, and we override model and tools here, as you can see. So you see that this particular model will get overridden when certain conditions are met, and that's why we need these middlewares to execute that. So let's see. We're loading load email E1 and draft a reply, right? So we're loading emails, and as you can see, I'm using mock data, and let's see what the E1 email is. So I have a bunch of emails. So you can see there are a bunch of emails. Contract renewal, need your sign off. Hire contract renews in 2 weeks. So this is a mock email that we are loading, and we'll execute that now. Okay. So let me go back to dynamic behavior, and let's look at this. Right. So we know that this is, from a VIP, and we are hoping that it picks up the relevant model. Okay. All right. So let's see. Here's the polished reply you can send to Jane. Hi, Jane. Thanks for the heads up. Da, 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 da. So we know, this is what was used. Now let's actually go to Langsmith and see what was the model that was used, and what was the system prompt that was used, right? So let's go to Langsmith now, and let's look at the latest. All right. interesting one, right? So we took close to 57 seconds and close to 4.6K tokens to finish this task. Not bad. So let's look at what the initial input from the user was. Load email E1, and I will show you what that email E1 is. In fact, I can show that to you right here. So load email E1 and draft a reply. So this was the input to the model. This obviously has the full graph of what happened. I don't want to show you that. I want to start from step one. So we sent this particular input. In the first iteration, it basically sent this particular input, and the load email, the LLM returned here, the model returned load email output. So if you see this, we are, we are basically, the input to this particular model was, you are Aria, the user's AI executive assistant. Be efficient used. This is a system model. The input was load email even and draft a reply. Because it realized that it needs to basically call a tool, the LLM here has responded back with a tool, which is load email. The harness then, that is the create agent harness, then took that tool and executed that. Basically, it gave that email ID, and we got this output from the email ID, which is basically this content here, as you can see. In the next iteration, the model then took that response back. The harness took that response from that particular load email tool and sent that. It basically executed that, right? We know that, and it added back to this. So let me show you this. And very important concept here. You see the state here has changed, and I'll show this to you. So we are sending this input to the model. Uh, Again, we are using the create iteration. We are iterating on that. So we know that this was the original user query. This is the assistant's response, and we have the tool response all added as context to the model. The model is looking at it like this, right? You see the state has the messages from the chat history, which is basically the what tools were called, the original message and all of that, but it also has the state, and as you can see, the is VIP true. So that's why the VIP aware prompt wrap model was invoked. And as you can see here, if you go back here, so we have updated the system model here. And if you see, this is the VIP aware system model, and sorry, system prompt. If I show you, if I can go back here and show you the system prompt, you are Aria, the user's AI executive assistant. This sender is a VIP, right? That's exactly what you're seeing. You're Aria, the user's AI executive assistant. This sender is a VIP. Take your time, be thorough, and use draft thorough reply, right? And we got this clear response. So if I can show you the final output here, load email, even and draft reply. And this is the response that we called. So it first, returned with the tool response, then the tool was executed. And then, we used the draft thoughtful reply prompt to essentially uh, respond with this, and a polished output was sent back the to the user. Now let's change this. I can show you. We'll actually pick a not so important message. So we'll pick E3, which is basically looks like it's coming from a colleague. Quick coffee next week. We know that this is not a message coming from a VIP. So we will change the prompt in our agent and say load E3 instead of E1. Let's do that now. I'm going to clear this. It's going to take some time, but all right. So the response we got is, "Hi Sam, nice to hear from you. Tuesday or Wednesday works for me." So it has already left a reply. Let's quickly go back and see what is the too close to 95 seconds, which is not very good, but let's see what it did. You see that it is using a simple model, which is GPT-5 Nano for this particular task. And let's actually see what prompt did it actually use to call that model. We'll go to the section here. Okay, so your Aria, the user's AI executive assistant, this is a routine email. Be efficient and use draft quick reply. So it has basically used the simple prompt and not the VIP prompt or the standard prompt to execute this particular task. All right, I think we are set for the final section now. Thank you. Let's quickly take a look at what are all the components that we are using in the final agent now. As you can see, we are using real MCP servers, that is the Gmail MCP server and the Notion MCP server, which means that we need to use LangChain's multi-server MCP client to connect with those MCP servers. We are also using the tool runtime to essentially inject the state during a tool call at runtime, that is. And we are using the dynamic prompt middleware to pick the relevant system prompt at runtime so that the harness has access to different system prompt depending on certain scenarios. We just discussed that in the previous section. We're using the wrap model call, as you can see here. And we are also using a multi-agent system. We have an email researcher agent, as you can see. We have a Notion researcher agent here. And yeah, those are the two different agents that we have added. We've added also created tools for that. Basically, we'll be using those agents, the sub agents, as tools in the supervisor agent that the supervisor pattern that we learned in section 4 essentially, right? So all put together, this is how the create agent uh, method looks like when we are building the agent, the main agent, that is. We are using GPT-5 Nano as the main LLM. We are using, or we are passing all the different tools that we have using this call email researcher, call Notion researcher, basically the different agents and tools that we have here. We are using state schema, Aria state, and Aria state essentially has the same is VIP. Let me go back there. You can see it's an extension of the agent state, and it has this particular property added, is VIP. And if I can get back to the create agent object again, we're using a couple of middlewares. The first one is VIP aware prompt, so that we pick the relevant prompt for relevant emails only. Same with model. We want to pick a stronger model for VIP emails. And we're also using human in the loop middleware for tools that have write access, or essentially tools that can either send emails or reply or write back to Notion, right? So we've discussed all of that. So we are using middleware, we are using checkpointer, we are using state schema, and we are using agents or sub agents as tools, right? Just to simulate a chat application, we'll be using a loop essentially, and we will be using multi-turn conversations here using a chat interface. So I mean, I can use the console to essentially give inputs and get responses as well. One important note is just to simulate a situation or a scenario here, I have, using my personal ID, I have sent an email to my Gmail account, as you can see, the one that we have given the access to. Let's assume that I am, the executive assistant, and I have got an email from my boss. Sorry, let's say that I'm the user. I'm using an AI executive assistant, and I've got an email from my boss. He wants the deck to be ready by evening. So that's the email that I want Aria to read now. Okay, I'm going to clear this, and I'm going to run the application now. I will essentially run the agent, and I'm hoping that at real time we are able to see. So what I'm going to do is I'm going to give it a prompt. It need not be a chat application. You can imagine this to be a continuous running loop also, but just to simulate how the agent works, we're going to give this. So I'm going to say read email from Zahiruddin Tawargere. He is my CEO. Or let me actually rephrase this. Check if there is, check if I have received an email from my CEO, Zahiruddin Tawargere. So let's see if it is able to essentially make the relevant tool calls. Uh, Obviously, we are using memory, so this is like a proper chat application now because I'm using a terminal to chat with the agent. All right, so it has received. Yes, you have emails from your CEO, Zahiruddin Tawargere. The latest email is urgent, board deck needed, and it was sent this morning. Can you pull together this? Right, so perfect. Now, what I intend to do is I'm telling it, reply to that email. I'm saying that I will keep the deck ready. So let's see if it actually sends out an email. So as you can see, it is asking for my approval. I'm going to say, it's asking if I want to approve this because the human in the loop has kicked in. I'm going to say yes, and let's see what happens. So it is saying that I've replied to Zahir, confirming I'll compile the Q3 numbers and have the board deck ready with a draft to him by 5:30 p.m. Now let's actually check this if that was done. I don't know if I will be able to find that. Yes, you can see that it has actually sent it to me. Hi Zahir, on it, I'll compile the Q3 numbers and I'll send you a draft by 5:30 p.m. for a quick look. I'm also checking my actual email now to see if I have that. As you can see, I have received the response from my email, and this is basically the email that I have received. All right, folks, what we just did was we used LangChain to go from All right, folks, what we just did was we used LangChain to go from a simple agent. All right, so, all right, all right, folks, here's what we did, right? We basically built an AI executive assistant, and we started from making simple bare LLM calls to building a dynamic agent that does course correction, picks up the right model, the relevant prompt at runtime to execute tasks, is able to connect with multiple MCP servers, is able to pick the relevant tools, call those multiple servers, and execute the task for us. I hope this was useful for you. I hope this was something that you can implement and take this to production. I think the natural next step is to basically build a chat application that is a UX for the agent and deploy this. But that is out of scope of this particular tutorial. Maybe we do that next time. But I hope you were able to learn something from this particular tutorial. Thank you so much. Please do subscribe if you haven't subscribed already. We'll catch up in the next one. Bye.